Okay, here we want to look at trigonometric integrals, specifically of the type sine x times cosine x. So the first thing we want to look at is the problem on the left where we have sine cubed x times cosine x. Now the first thing that we should notice is that the cosine x is raised to the first power. Of course, if we don't see an exponent here, it's an understood 1. Okay, so we can draw it right there. So now, this tells us that we can go directly into u substitution, which is the traditional way to do a problem like this. So of course, we would say u is equal to sine x, and du would be equal to the derivative of sine x, which was cosine x dx. Now on our next line, instead of sine cubed, we use that substitution, which is u cubed. And instead of cosine x dx, we use this substitution, which was du. As we know, the antiderivative of u to the third would be u to the fourth over 4 plus our arbitrary constant c. And for the end of the problem, we just substitute this back in, which is sine to the fourth x over 4 plus c. Now, this is where the trigonometric integrals and the substitution comes in. Now notice the problem on the left, the cosine was to the first power, but here on the right is to the fourth. So we're going to look at this special case. So remember, our goal is to execute u substitution, but before we could do that, we have to have one of our functions down to the first power. So let's look at how we'll do this. Now the first thing we want to do is we want to separate our sine. So remember, initially we had sine cubed, which was basically sine, sine, and sine. On this second line, we still have those 3 sines, but we separated it into sine squared and sine x. This process is called saving a sign. Okay, where we saved it at the end. Okay, so now we want to use a trigonometric substitution. So if we recall from trigonometry, you had Pythagorean identities, and I'm going to underline this. Sine squared could be rewritten as 1 minus cosine squared. This is times cosine fourth to the x times sine x. Okay, this is coming from the old trigonometric identity, the Pythagorean identity, where it said sine squared x plus cosine squared x is equal to 1. Okay, so now on this next line, once again, we just have to use our distributive property. So 1 times cosine to the fourth is cosine to the fourth minus cosine to the sixth times sine x. Okay, now we've done everything we could do, but we also have sine to the first power. Remember what we said, if it's not seen, the 1 is not visibly there, it's understood to be a 1. We've gone as far as we could go here. So now we know it's time to use u substitution. So we'll go to the higher power. U is going to be equal to cosine x, and du is equal to negative sine x dx. Remember, the derivative of cosine will yield us this negative sign. So now we make our proper substitutions. Instead of cosine to the fourth minus cosine to the sixth, this is going to give us u to the fourth minus u to the 6. And instead of sine x, we use du. But this negative we need to bring out front. And we're talking about this negative right here. Okay, we're going to take that and bring it out front. And now we can find our antiderivative. The antiderivative of u to the 4th is u to the 5th. And the antiderivative of u to the 6th is u to the 5th over 5, I'm sorry. And the antiderivative of u to the 6th is u to the 7th over 7. But remember, we have to distribute this negative sign through. All right? So in the end, and we know it's customary, a lot of times we start with the positive, so we will say cosine 7 over 7 minus cosine to the 5th x over 5 plus c. And these are just the way we use our trigonometric integrals. The key step right here is remembering that sine squared x is equal to 1 minus cosine squared x. And I want to show where this comes from on my scratch paper. If we remember, there was a Pythagorean identity that said sine squared x plus cosine squared x equal 1. Therefore, anytime you see sine squared x, we know we can replace that with 1 minus cosine squared x. And anytime we see cosine squared x, I'm going to put it over here, we can replace this with 1 minus sine squared x. So that's what we did with these steps underlined in red.